Welcome to Math is Fundamental. Today we're going to be talking about perimeters and areas of similar figures. So let's start off with an example. We have two figures here and we're going to assume that they are similar figures, and we're going to find the perimeter and area of each and then look at how they compare to each other. So let's look at the first figure here. We have a trapezoid, an isosceles trapezoid, so we know that that side is also 5 meters. The perimeter, if I add up all my sides, I get 34 meters. And my area of my trapezoid, which we reviewed in one of my previous lessons, is 1/2, and then 9 plus 15, so base 1 plus base 2, and then times the height of my figure, which we can find by drawing our height using the fact that these are both an isosceles trapezoid. If both of the legs are the same, then these two distances are both going to be equal. If this is 9, I can take 9 from 15 and then split it in half. So this is going to be 3 and 3. And then using my right triangle, you can use Pythagorean theorem, but this side is going to be 4. So my height of my trapezoid is 4, and I have 1/2 of 9 plus 15 times 4, which gives me 48 meters squared. All right, now if we look at our second figure, we're going to assume that these two figures are similar. And to find the scale factor to use to find my other sides, I'm going to take the first figure and a corresponding side of my second figure. So that would be like the 9 meters and then 6 meters, and then reduce it. So I can use the scale factor of 3/2 or 2/3. If you flipped it over, that's fine, to find my other sides here. So applying that, I know that this side is going to be 10 meters. And let's see, these are going to be 10/3 meters here and here. So my perimeter, when I add all these together, I should get 16 plus, let's see, 20 over 3. That's going to be 16 plus 3 goes into 20. 6 times with 2 left over, and then that's going to be 22 and 2/3. So not the easiest number to work with, but there we go. And then the area of this figure, if I use the same right triangle I have here and split it up into 2, 2, and then my 6 to make up the 10, and use my Pythagorean theorem, I am going to get 8/3 for the height of my trapezoid. Setting up my area, 6 plus 10 times our height, 8/3 over 2, is going to give me 21 and 1/3 meters squared. All right, and I'm just not calculating them right now because it takes time. So now if we look at the ratio of the perimeters, if I look at 22, or let's take the first one on the top. If I do 34 over 22 and 2/3 and simplify that, which might take a little while there, okay, I will get 3/2, which is the same thing as my scale factor. So kind of a complicated example to look at with our fractions and mixed numbers there, but it does simplify down to 2/3, which is really, really neat. All right, now if I take my ratio of my areas, 48 over 21 and 1/3, and I simplify that down, I end up with 9 over 4. And if we look at our scale factor and our ratio of our areas, we'll see a pattern. The ratio of the areas is actually just the scale factor squared. So let's put this in here. If the scale factor of two similar figures is A over B, then the ratio of the perimeters is going to be the exact same as the scale factor. It's just going to be A over B. And the ratio of the areas is going to be A over B squared, or A squared over B squared. All right, so shorthand, if the ratio of the sides is R, then the ratio of the perimeters is R, and the ratio of the areas is R squared. Sneak peek to a future lesson, the ratio of the volumes is going to be R cubed. Really, really neat the way that works out. All right, so let's look at some examples. Find the scale factor, the ratio of the perimeters, and the ratio of the areas. So it's not actually asking us to find the perimeter of the areas, it's just asking us to find the ratios. So my scale factor here And it doesn't tell me which one has to go on top or bottom, so it doesn't really matter. So I'm going to go with the first one on top, so I have 7/5. That means the ratio of the perimeters is also going to be 7/5, and the ratio of the areas is going to be 7/5 squared, or 49/25. So we can use those. If we know the area or perimeter of one of them, we can use that ratio to find the area of the other one. We'll see an example in just a minute. All right, now this one's a little trickier. When we find our scale factor for this one, you're going to want to separate the two triangles. So just a little review. So we want to separate the small triangle from the large triangle. We have 6 here, and the length of the large one is 8. So don't just use the 6 and the 2. We want to separate them and really look at the side lengths of our two similar figures, which are both triangles. So our scale factor is going to be 6 to 8, or 3 to 4 when I reduce that, which means my perimeter ratio is going to be 3 to 4, and my area ratio is going to be 9 to 16 when we square 3 and 4. All right, next example. If the area of the smaller pentagon is about 27.5 square centimeters, what is the area of the larger pentagon? So first what we want to do is find the scale factor, which would be 4 to 10, which reduces to 2/5. Now it's telling me the area, so now I need to find the area ratio, and the area ratio is going to be 2/5 squared, which is 4 to 25. So now, if the smaller rectangle area is 27.5 and the smaller rectangle is the 4 part of our area ratio, 4 to 25, my 27.5 is going to go on the top because I'm putting my smaller figure on the top, my larger figure on the bottom. I'm finding the area for my larger figure. So notice I've set up a proportion here using the area ratio and the area that they gave me of my, my smaller figure. So now, if I solve this, I cross multiply, I get 4x equals 25 times 27.5 and divide by 4. We end up with 171.875, and our units are centimeters, and we want to square that for area. So there is our area of our larger pentagon. All right, and last example, they're telling us that the rectangles are similar, and we need to find the ratio of the perimeters. Remember, that's the same thing as the ratio of the scale factor. All right, so they gave us the areas. So what we're going to do is we're going to take the ratio of the areas and simplify it down. So if I simplify these down, I can, well, let's see, let's divide by 2. If I divide by 2, I get, let's see, that's 100, and that's going to be 256. All right, and then if I set that equal to a squared over b squared, or a over b squared, like this, I can solve for a over b by square rooting both sides. So I can take the square root of both sides, 256. The square root of 256 is 16. Square root of 100 is 10. And we should simplify that to 8 over 5. And there's the ratio of our perimeters. All right, and that concludes our lesson for today. Thank you so much for watching. And remember, math is fundamental.